In this video, we'll learn about what product and quotient rule mean. We'll also learn how to apply these rules to find the derivative of the given function. What is product rule? The product rule says that if we need to find the derivative of the two functions, let's say f and g, then the derivative of the product of these two functions f and g will be f as it is multiplied by the derivative of the g plus the derivative of the f times the g function as it is. Let's see one example. Let's say we need to find the derivative of 3x squared plus 1 times 7x minus 3. As we can clearly see that here we have product of two functions. So let's assume that 3x, the first function 3x squared plus 1 is f, and let's assume 7x minus 3, the second function is g. Then if you want to use the product rule, then you might have noticed that we actually need to also find f prime and g prime so that we can directly use this rule. So let's find the derivative of f and derivative of g. So what is the derivative of f? Derivative of f will be 6x, right? By using the constant multiple rule, we can take 3 out, and then derivative of x square with respect to x will be 2x, right, by the power rule. So 2x times 3 will be 6x, and derivative of 1 with respect to x will be 0. Why is that? Because of the constant rule. So we just have 6x here. Similarly, what is the derivative of 7x minus 3? The derivative of 7x minus 3 will be, what is the derivative of 7x? 7 as it is, and derivative of x with respect to x is 1, so 1 times 7 will be 7, and derivative of 3 will be 0. So by the difference rule, the derivative will be just 7. So now we have f, g, f prime, g prime. Then now we can directly use this rule. So to find the derivative of 3x squared plus 1 times 7x minus 3, if we assume f is 3x squared plus 1 and g is 7x minus 3, then let's plug in these information on this formula. So we write down first, let's say f times g prime, right? So f is 3x squared plus 1, that's what we have assumed, so write that down. And then g prime is 7, so let's write that down, and then plus f prime, so f prime is 6x, write that down, and times g, so let's plug that in. So we have f times g prime plus f prime times g. We are done. This is the derivative. But if we want to simplify this, you can clearly see that we can distribute by 7, and then this is what we get here, right? So 7 times 3x squared will be 21x squared, 7 times 1 will be 7. In the same way, 6x times a positive 6x times 7x will be 42x squared, and 6x times negative 3 will be negative 18x, and we can combine these like terms. So 21x squared plus 42x squared will be 63x squared, and negative 18x plus 7 is the derivative of this product function. Now let's learn about the quotient rule. Let's assume we have a cosine function which is represented by f over z, and if our goal is to find the derivative of this cosine function, then the derivative is obtained by this rule, which is write down the function of the bottom as it is times the derivative of the top minus write down the top function as it is multiply by the derivative of the bottom function, and everything divided by the square of the bottom function. Let's try to see an example. Let's say our goal is to find the derivative of 3x squared plus 1 divided by 7x minus 3. So we have a cosine function here which is represented by 3x squared plus 1 over 7x minus 3. So we can clearly use the quotient rule here. So to find the derivative of this function by using the quotient rule, now we need to assume which one is f and which one is g. So let's assume f is 3x squared plus 1, whatever function is in the numerator or at the top. Okay, Let's assume 7x minus 3 is g, or whatever function we have on the bottom. Let's assume that by g. So g is 7x minus 3. So we can see now when we assume what is f, what is g on this formula, we also need to know what is f prime and what is g prime. So if we assume what is f and g, let's find what is f prime and what is g prime. That means find the derivative of f, find the derivative of g. So what is the derivative of f? What is the derivative of 3x squared? 6x, right? What is the derivative of 1? 0. But 6x plus 0 will be 6x. So derivative of 3x squared plus 1 will be 6x. Let's try to find the derivative of z. How do we get 7? Well, 7x, say if we apply the constant multiple rule, 7 is as it is. Derivative of x with respect to x is 1. So 1 times 7 is 7. And derivative of 3 with respect to x, since this is constant, so derivative will be 0. So 7 minus 0 will be 7. So we have f, z, f prime, g prime. So those are the only variable we need over here to plug back in on this rule. So if that is the case, let's try to apply the quotient rule here. Okay, so this is the derivative, this is the function whose derivative we need to figure out, and we already have all the necessary information. So our goal is to just plug that information in this formula. So let's begin with the numerator. So here is z, so replace that by 7x minus 3, and replace f prime by 6x, replace f by 3x squared plus 1, replace g prime by 7, and on the denominator we need to have the square of g, and we can then square the 7x minus 3. Okay, so we can see here, so this is our g, this is your f prime, this is our f, right, on the formula, you can check that, and then this is our g prime, right? So that's on the formula, and then that's what we have obtained. Everything on the numerator, what we have over here, is divided by square of the 7x minus 3. Done. This is the derivative of this function 3x squared plus 1 divided by 7x minus 3. But this doesn't look like on the simplified form, so let's try to see if we can simplify and write down in an alternative form. Okay, so we have already, by using the quotient rule, we have already figured out the derivative. But on the numerator, I see couple of terms over here which I could distribute, like 6x can be multiplied with 7x, so that will be 42x square, right? Minus 6x times 3 will be 18x, and the same way we can distribute here by the 7, and then we get 7 times 3x square is 21x square, 7 times 1 is 7. So let's distribute that, and here is minus, so let's distribute by minus 1 and remove this parenthesis over here. When we do that, negative 1 times 21x square will be negative 21x square, negative 1 times positive 7 will be negative 7. Here we just have the positive 1, so no problem with that, we can write down as it is. And we have the like term that we can combine, so 42x square, and then we have 21x square, right? So negative 21x square, when we combine we get 21x square, and then the rest of the others are unlike terms, so we can just carry it, and on the denominator we can just leave it like that.